Let's take a look at this physical and chemical changes activity from small group. Your assignment was to define a physical change and a chemical change, and then to identify the observations that you made as either being physical changes or chemical changes. A physical change can be defined as a change in the form of a substance, but not in its chemical composition. During a physical change, no chemical bonds are broken or formed. A chemical change is a change of a substance into other substances through the reorganization of atoms. Basically, a chemical change is analogous to a chemical reaction. Next, you are supposed to go back to all the observations that you made during the activity and identify what you observed as either a chemical change or a physical change. This is one of the hardest things for a beginning chemistry student to do. So I understand if you might be frustrated. In fact, I'm sure some of you said, "I don't get it," or "this is hard," or maybe even, "I give up." Hopefully, the next thought that popped into your head was, "Please help me." Now, the word thought should have alleviated some of the stress, because all I'm looking for is a guess as to whether you think this is a physical change or a chemical change. When I was a beginning chemistry student, identifying physical and chemical changes was one of the hardest things for me to do. What made it finally click for me was simply asking myself, did I make something new? If I made something new, I knew the change was a chemical change. If I did not make anything new, then I knew the change was a physical change. Once I could consistently answer the question, did I make something new, I became much better at identifying physical and chemical changes. So the next question you might ask yourself is, well, how do I know if I made something new? And that is a good question. There are certain things that you can observe about a change that will hint towards it being a chemical change. We need to be really careful here when we talk about these indicators of a chemical reaction, because they are not always 100% true. One indicator that a chemical reaction may have occurred is a color change. The second indicator that a chemical reaction may have occurred is a change in temperature. And finally, the production of a new phase, a solid, liquid, gas, or aqueous solution, may also be proof that a chemical change has occurred. It is important to note that if a new phase is produced, the chemical formula of the new substance must be totally different from any other formulas in the reactants. Now I know what you're saying. What do you mean? Well, here's a couple examples. If I were to have a beaker of salt water and I heated it up, after a period of time, what observation would you make? Same with a beaker full of liquid ethyl alcohol. If I were to heat up that beaker of ethyl alcohol, after a certain period of time, what would you observe? Or maybe even a piece of dry ice, solid carbon dioxide. If I let that sit on the counter for a period of time, what would be your observation? Start by asking yourself the question, did I make something new? For the beaker of salt water, you would start off with a colorless solution, and as the beaker was heated, the water would evaporate. You would be left with a white solid, the salt. And you may think, oh, a color change, I made something new. But that is not the case. What you started with was salt dissolved in water. What you have in the beaker now is salt in the solid form. You haven't made anything new. How about the ethyl alcohol? Did you make something new? Well, if you heat up the ethyl alcohol, all you're going to do is end up boiling the ethyl alcohol. You would start with ethyl alcohol in the liquid phase and end with ethyl alcohol in the gas phase. So you might think, hey, I got a new phase. But no. The substance that is produced in the process must have a different formula than what you started with. But you started with the alcohol and you ended with the alcohol. So you didn't make anything new. All you did was boil it. Did you make something new when it came to heating the dry ice? Once again, dry ice is simply turning from the solid phase to the gas phase. All it is doing is subliming. You did not make anything new. Even though there is a phase change, the substance produced, CO2 gas, is the same as the substance you started with, CO2 in the solid phase. Notice all three of these changes involved phase changes, evaporating, boiling, subliming. One easy thing to remember is that phase changes are always physical changes. What about this one? What if I take some solid salt and I put it into water to make an aqueous solution? In other words, I dissolve it. Well, did you make anything new? The answer is no. You have solid salt to start with, and you finish with salt dissolved in water. You did not make anything new. Dissolving is always a physical change. Well then, what would be an example of a chemical change that results in a new phase? One example I can give you is when you mix two aqueous solutions and a solid is formed. In this case, you get a phase change and the substance that is made is different from the reactants that you started with. Let's apply our new knowledge to the observations from the lab. So you started by adding some copper chloride to water and stirring until it disappeared. You should have observed a blue solution. The question is, did I make something new? The answer is no. You simply dissolved the solid copper chloride and made an aqueous copper chloride solution. As we just discussed, dissolving is a physical change. The new phase you observed was not the result of a new substance being formed. In step 4, you added an ice cube to your copper chloride solution and stirred until it disappeared. The observation you should have made is that you still have a blue solution, but now it is a little cooler. So did you make something new? The temperature changed. The phase of the ice cube changed. This is true, but what happened to the ice cube? The ice cube simply melted. Melting is a phase change, and phase changes are always physical changes. For step 6, you added a strip of aluminum to the blue solution. You should have observed a red solid forming, bubbles forming, the test tube becoming warmer, and if you waited long enough, the solution became colorless. Did you make something new? Well, there was definitely a color change. You started with a silvery metal in a blue solution, and you ended up with a red solid, a colorless gas, and a colorless solution. You also observed a temperature change, and a new phase was produced, a gas. In this case, you observed all three indicators of a chemical reaction. This was definitely a chemical change. In the next test tube, you added a piece of magnesium metal. You should have observed a red solid, the formation of bubbles, and the solution became cloudy. Did you make something new? Once again, you have a color change, and you also have a new phase produced, a gas. Magnesium metal reacts with copper chloride solution just like aluminum metal does. So this was definitely a chemical change. In test tube 8, you added several drops of sodium hydroxide. You should have noticed a light blue solid form. So did you make something new? Well, the solid that was produced and the solution have very similar colors, so that might not count. But you did produce a new phase. You mixed two aqueous solutions and got a solid. If you remember, that's the example I just shared with you a few moments ago. This is another chemical reaction. Therefore, it is a chemical change. Potassium chromate was added to the next test tube. You should have observed a red solid and the solution turns from blue to green. Did you make something new? Definitely had two color changes. The red solid and the solution changed from blue to green. A relevant phase change was also observed. Two aqueous solutions were mixed and a solid was formed. Yet again, you have witnessed a chemical reaction. Therefore, a chemical change. This next test tube is a little deceiving. You added some calcium chloride to the solution of copper chloride. Did you make something new? You may have observed a yellowish color in the bottom of the test tube, and based on what we have discussed here, a color change would indicate a chemical reaction. However, if you took the time to mix the tube, you would notice that the yellow color goes away. No new substances are formed. The calcium chloride simply dissolves and mixes into the copper chloride solution. Mixing is a physical change. Onto the candle. You started by simply lighting the candle and observing. You should have noticed that the wick burns and the wax melts. Did you make something new? Well, the wick is burning and heat is being produced. A chemical reaction is taking place. Burning is always a chemical change. What about the wax? All the wax is doing is melting. Melting is just a phase change. Phase changes are always physical changes. For step 11, you should have observed both a physical and a chemical change. When you blow out the candle, you end the chemical change. However, you should have observed the wax freezing. Did you make something new? Freezing is a physical change. No new substance was formed. Wax simply changed from the liquid phase to the solid phase. The final interaction you witnessed was placing a pellet of calcium carbide into the water. You should have observed rapid bubbling and formation of a gas. The water turned cloudy white, and when a flame was applied to the gas, it ignited. Did you make something new? Well, we took a brownish solid, added it to colorless water, and produced a cloudy white solution. So there's a color change. There was definitely a temperature change because you could ignite the gas. And you added a solid to a liquid and produced a gas. So there was a new phase produced. You have all three indicators of a chemical reaction. Therefore, it's very reasonable to assume that this is a chemical change. Also remember that burning is always a chemical change.